Okay, let's move to revision 2. Okay, this one is from Gerak Kerja 59, question 1. Okay, another distance time graph. Okay, the distance time graph show the journey of a bus and a car. Yeah, so graph OQR represent the journey of the bus. Yeah, bus from town X to town Y. So this is for the bus, the red color. The graph MQN represent the journey of the car. Yeah, this one is the journey of the car from town Y to town X. Okay, and of course you can see the graph going back. Yeah, the blue color. Okay, so question A, calculate the average speed in kilometer per hour of the journey by bus from X to Y. From X to Y, that means let us focus the bus, yeah, this one, the red color. Okay, again, the average speed is use this formula, and the time is of course this one, yeah, 320 kilometer at the distance over the time is 4 hours. Yeah, so you'll get 80 kilometer per hour. This is the average speed. Yeah. Okay, for B, given the car moves at a uniform speed, yeah, move at a uniform speed, calculate the value of t. Okay, this time car, right? So we focus on the blue color, yeah, the blue graph. Okay, as you know, uniform speed, yeah, this one, the uniform speed, the gradient will be the same. Yeah, anyway you take, the gradient will be the same. So let's say speed MQ, yeah, speed MQ, this one, the speed, this one over this one will be the same as speed MN, this one, the big one. Yeah, it will be the same. Okay, do you get it? Okay, let us make it clearer. Lah. I use another color, black color lah. Okay, again, speed MQ, the speed, yeah, this one over this one will be the same with the speed MN. MN is this one, MN. So will be the same, will be the same value, because it is uniform speed. Okay, meaning gradient is the same. Yeah. Okay, so let's find the gradient. We make one equation so that we can find what is t. So this one MQ will be 320. You have to minus 200 over t, this one, t, and then your MQ is of course 320 over 4. So you solve it, you find your t is 1.5 hour. Yeah, your t is 1.5 hour. That's the answer. Okay, next is Gerak Kerja 61, question B. And finally, we reach speed time graph. Yeah. Okay, the question is, the speed time graph shows the motion of a particle of a period of 17 seconds. Yeah, the time is in seconds. Describe the motion of the particle. Yeah, you are going to describe for the period of, okay, these are the 3 questions. Yeah. So first, the question is the first 5 seconds. So where is the first 5 seconds? Okay, the first 5 seconds will be here. So the graph here is what happened. This is a speed time graph. Yeah, speed time graph. So this one, what do you call this graph, this part? It's the acceleration. Yeah, so you have to mention acceleration for the first 5 seconds. The particle accelerates. Yeah, accelerates at a rate of 3.6. okay, how do you get 3.6? It's not in this graph, so you have to find. Yeah, for the first 5 seconds, this is 5 seconds. So how do you find A? How do you find the acceleration? So you have to remember acceleration is the gradient. For speed time graph, the gradient is the acceleration. So what you do is you find the gradient. Yeah, 24 minus 6 over 5. Yeah, this one over this one. Okay, so that's where you get 3.6. Yeah. Okay, next for B, the next 7 seconds. The next 7 seconds will be where? Next 7 seconds will be here. So what does the graph tells you? It is at, the speed does not change. It is at uniform speed. It doesn't change. You can see the parallel to x-axis doesn't change. So this is quite easy. You just say the particle moves at a uniform speed for this one, 24 meter per second square from the 5th second till the 12th second. Yeah, this one, 5th second to 12th second. Okay, next for C, for the last 5 seconds. For the last 5 seconds, it will be where? It will be here. Yeah. So what do you call this part? This part of the graph going down. So you have to mention it is a deceleration. Yeah, deceleration. So it decelerates at the rate of, okay, what is the rate? 4.8. Yeah, how do you find 4.8? You just find the gradient. Yeah, you find the gradient. So you get this 24 minus 0, 17 minus 12, you get 4.8. Yeah, meter per second square. So decelerates. Okay, the opposite of accelerates. So that's how you describe. Okay, please check your answer. Is it right or not? Okay, next, Gerak Kerja 62, question 1. Yeah, this one is also a speed time graph. So normally, be careful every time when you come across a graph. Yeah, in graph of motion, you must check. Yeah, first thing you must check what type of graph it is. Yeah, so this one is speed time graph. It shows the motion of a particle for a period of 11 seconds. Yeah, so the question is calculate the total distance in meter traveled for the first 8 seconds. Yeah, so distance, how do you find distance? in a speed time graph? Still remember? You're not using any formula. Yeah, you cannot use this one. DST, this one, no. There is a formula, another formula. Yeah, that is what? This one. Okay, for speed time graph, the distance is area under the graph. You just find the area under the graph. So for the first at seconds, this is the first at seconds. So the graph for the first at second is here. Yeah. So under the graph here, what shape do you see? Okay, you see two shapes, that is A and B, a trapezium and also B, a rectangle. So you just find the area. Yeah, area A plus area B. So area A is use the trapezium formula. Yeah, 1/2 times this one, the height, and then you times with the parallel length. Yeah, this one and this one. Yeah. And then for area B is very easy, it's a rectangle, so 6 times 8, so you get 60 kilometer. That is the distance, yeah, for the first 8 seconds. Okay, next the question is state the uniform speed of the particle. So where is uniform speed? Because this is a speed time graph. Uniform meaning the speed does not change. Speed does not change is where? Of course here. Yeah, the one parallel to x-axis. Okay, so state the uniform speed. How do you state? Uniform speed is at 8 meter per second. That is the uniform speed. Yeah? Or you can write also meter per second. This is just how you write. Okay, next for C. Given the rate of change of speed for the last 3 seconds is 2 times the rate of change in speed for the first 2 seconds. The last 3 seconds is where? This is the last. This is the last 3 seconds. Yeah? Okay, and then the first 2 seconds, this one. Okay, there is a relationship over there, 2 times. Okay, so what do you understand by the rate of change of speed? This is another words for acceleration, yeah, or gradient. Rate of change of speed, yeah, of speed is actually equal to acceleration. And how to find acceleration? You just find the gradient. Okay, this one applies only for speed time graph. Okay, just for your revision, rate of change in distance is what? Okay, this is equal to speed only for distance time graph. Okay, but for speed time graph, the rate of change of speed is called acceleration. Okay, hope you get it. Okay, now we go back to the question. Yeah, go back to the question. So what you do is, this is the first 2 seconds, and that is the graph. This is the last 3 seconds, and this is the graph. So first 2 seconds, the acceleration is this one, at -4 divided by 2, so you get 2 meter per second square. And then for the last 3 minutes, what do you get? V minus 8 divided by this one, yeah, that is 3. Okay, so you get, you make connection here. You know that from here, the last 3 seconds is 2 times the rate of change in speed for the first 2 seconds. So 2 times for the first 2 seconds. This one. These 2 come from here. These 2 is because of 2 times, yeah, from the question. So you solve your V. You get V is 20, right?